The cumulus cloud. This is the cloud almost every human being learns before they learn the word cloud itself. Ask a child to draw the sky, and chances are they'll draw a giant fluffy cumulus cloud. White, soft-looking, rounded on top, flat on the bottom. It looks harmless, comfortable, almost edible. If clouds had mascots, the cumulus cloud would probably be it. But appearances can be deceptive. The cumulus cloud begins its life in an incredibly simple way. The sun heats the ground. The ground heats the air above it. Warm air rises because it's lighter than the surrounding atmosphere. As the air climbs higher, it cools. Eventually, it cools enough for invisible water vapor to become visible droplets. Suddenly, a cloud appears where there was nothing moments earlier. What you're seeing isn't smoke. It isn't steam. It's billions upon billions of microscopic water droplets suspended in the air. The fascinating part is that every gigantic storm cloud you've ever seen started exactly this way. Every thunderstorm, every hurricane cloud, every towering monster cloud that produces lightning. They all began as small, innocent cumulus clouds. Meteorologists sometimes call young cumulus clouds fair weather clouds because they often appear during calm sunny days. But they're also constantly being monitored because some of them evolve, and when they evolve, things get interesting. Throughout history, humans have attached meanings to cumulus clouds. Ancient farmers often watched them carefully. Sailors studied them. Travelers judged weather based on their size and growth. Long before weather apps existed, clouds were forecasts. In many ways, they still are. A tiny cumulus cloud on a warm afternoon isn't particularly remarkable. But when dozens begin growing rapidly upward, experienced weather watchers immediately pay attention because they're witnessing the first chapter of a much larger story. The cloud world has childhood stages, and the cumulus cloud is where many of them begin. The stratus cloud. If cumulus clouds are the cheerful extroverts of the sky, stratus clouds are the quiet pessimists. These are the clouds responsible for those gray days, where the entire sky seems covered by a giant blanket. No dramatic shapes, no giant towers, no beautiful sunsets, just gray, endless gray. Stratus clouds form low in the atmosphere and spread horizontally rather than vertically. Instead of building upward like cumulus clouds, they stretch outward, often covering enormous areas. They're among the most common clouds on Earth, and they're probably responsible for more complaints about weather than any other cloud type. What's fascinating is how deeply they affect people psychologically. Researchers have repeatedly found connections between weather and mood. Less sunlight can influence energy levels, emotions, productivity, and even sleep patterns. While clouds themselves don't cause sadness, many people genuinely feel different during long stretches of overcast weather. Entire cities have reputations built around this. Places famous for cloudy weather often develop cultural identities around gray skies. The cloud itself isn't dangerous, but it changes the atmosphere in more ways than one. Historically, stratus clouds have also caused major challenges for navigation. Before modern instruments existed, low cloud layers could completely hide landmarks. Travelers became lost. Ships struggled to navigate coastlines. Early pilots learned to fear low cloud ceilings because they dramatically reduced visibility. The strangest thing about stratus clouds is their simplicity. They don't create spectacular lightning. They don't create dramatic tornadoes. They don't create viral weather footage. Yet they quietly dominate the skies over huge portions of the planet every single day. Sometimes the most influential clouds are also the most boring. The cirrus cloud. Thousands of years before satellites existed, humans already knew cirrus clouds meant something. Ancient sailors watched them carefully. Farmers paid attention to them. Travelers learned to recognize them, because cirrus clouds often arrive before the weather changes. At first glance, they don't even look like normal clouds. Instead of fluffy shapes, they appear as delicate streaks stretched across the sky. Thin feathers, wispy threads, white brushstrokes painted across blue space. And unlike most clouds, cirrus clouds exist incredibly high above Earth, often over 20,000 feet, sometimes much higher. At those altitudes, temperatures become brutally cold. So cold that cirrus clouds aren't primarily made of water droplets. They're made of ice. Millions of tiny ice crystals floating near the upper atmosphere. This gives them their signature appearance. Sunlight interacts differently with ice than with water, creating the elegant wisps people recognize instantly. But cirrus clouds aren't just beautiful. They're messengers. Meteorologists know that increasing cirrus clouds can indicate a weather system approaching from hundreds of miles away. While the weather on the ground may still seem perfect, the upper atmosphere is already announcing change. The sky is sending a warning long before people feel the effects. This is why sailors once called cirrus clouds Mara's tails. Appearance of these clouds often suggested storms were on their way. For centuries, this observation helped people survive. Today, satellites can predict weather far more accurately. But the old sailors weren't wrong. The cirrus cloud still whispers the same message it has always whispered. Something is coming. The Cumulonimbus Cloud. This is the king, the emperor, the final boss of clouds. The Cumulonimbus Cloud isn't just a cloud. It's a weather machine. A single cumulonimbus cloud can grow over 60,000 feet high. To put that into perspective, many commercial airplanes cruise around 35,000 feet. Some cumulonimbus clouds are literally taller than aircraft. Standing beneath one can feel unsettling. They don't look like ordinary clouds. They look alive, towering upward like floating mountains, expanding across the horizon, growing darker as they accumulate energy. And inside them, chaos is unfolding. Powerful updrafts launch water droplets upward at astonishing speeds. Ice crystals collide. Moisture rises and falls continuously. Electrical charges separate within the cloud. Positive charges gather. Negative charges gather. The atmosphere becomes a giant battery. Eventually, that battery discharges. Lightning, thunder, rain, hail, sometimes tornadoes, sometimes destructive winds, sometimes flash floods. Virtually every weather event people fear can be traced back to cumulonimbus clouds. The amount of energy involved is difficult to comprehend. A single lightning bolt can contain hundreds of millions of volts. A major thunderstorm can release energy equivalent to multiple nuclear explosions. Yet despite all this power, the cloud itself remains breathtakingly beautiful. Photographers chase them. Storm chasers dedicate entire careers to following them. People drive hundreds of miles just to watch them form. Because cumulonimbus clouds represent one of nature's most spectacular displays of raw power. They remind humans of something easy to forget. The atmosphere above us isn't calm. It's a constantly moving ocean of energy. And sometimes that energy decides to introduce itself. The nimbostratus cloud. Most clouds want attention. Nimbostratus clouds don't. They simply show up and ruin your day. Not dramatically, not violently, just relentlessly. A nimbostratus cloud is essentially the atmosphere deciding that everything underneath it is going to stay wet for a very long time. Unlike thunderstorm clouds, these clouds don't produce dramatic lightning or thunder. They don't put on a show. Instead, they create steady, persistent rain that can last for hours, sometimes days. The entire sky becomes one giant gray ceiling. The sun disappears. Shadows vanish. Everything begins feeling muted. There's something strangely psychological about nimbostratus weather. The world becomes quieter. Roads become reflective. Sounds become softer. Time feels slower somehow. For centuries, prolonged rain from nimbostratus clouds shaped civilizations. Farmers depended on it. Cities feared flooding from it. Armies altered campaigns because of it. Entire harvests succeeded or failed because these clouds decided to linger. One of the reasons nimbostratus clouds are so effective is their size. They often cover enormous areas. You're not dealing with a local storm. You're dealing with an entire weather system. And once it's overhead, you're usually stuck with it. This cloud doesn't arrive to impress anyone. It arrives to outlast everyone. The altocumulus cloud. If clouds had secret warning signs, altocumulus clouds would be among the most misunderstood. At first glance, they look beautiful. Small white patches scattered neatly across the sky. Sometimes they resemble fish scales. Sometimes they look like hundreds of tiny cotton balls floating together in organized rows. The pattern can stretch from one horizon to the other. To most people, they're just pretty clouds. To weather experts, they're clues. Altocumulus clouds live in the middle levels of the atmosphere, usually between 6,500 and 20,000 feet. They're too high to feel close and too low to disappear into the upper atmosphere. They exist in a kind of cloud middle class. And yet they often reveal that something unusual is happening. When warm, humid air becomes trapped beneath cooler air higher up, altocumulus clouds frequently begin appearing. That instability can sometimes lead to thunderstorms later in the day. This is why experienced weather watchers pay attention when alto-cumulus clouds show up early in the morning. The sky may look calm. The atmosphere may not be. Ancient sailors called these formations mackerel skies because they resembled the scales of a fish. Old weather sayings even emerged around them. Mackerel sky and mare's tails make tall ships, carry low sails. In other words, if you saw alto-cumulus and cirrus clouds together, rough weather might not be far away. It's amazing how humans learned to read the sky long before satellites existed. Clouds were forecasts, and alto-cumulus clouds were among the atmosphere's most reliable hints. The altostratus cloud. Some clouds arrive dramatically. Altostratus clouds prefer suspense. Imagine looking up and noticing something strange. The sky isn't completely cloudy, but it isn't clear either. The sun is still visible, yet somehow it looks weak, blurry, ghostly, almost as if someone placed a giant sheet of frosted glass between Earth and space. That's usually altostratus. These clouds spread across massive regions of the sky, forming gray or bluish layers that gradually block sunlight. And perhaps their most interesting feature is what they often mean. They're frequently the opening act before larger storms. Meteorologists know that altostratus clouds often appear ahead of warm fronts and approaching weather systems. They can arrive hours before rain begins, sometimes even an entire day beforehand. The sky is essentially preparing itself. Nature is setting the stage. Throughout history, people noticed this connection without understanding the science behind it. Farmers, travelers, sailors, and shepherds all learned that certain clouds seemed to arrive before changing weather. They couldn't explain why, but they knew the pattern existed. And they were right. The atmosphere is constantly communicating. Most people simply don't know how to listen. The stratocumulus cloud. If clouds were ranked by personality, stratocumulus clouds would probably be described as lazy. They don't grow dramatically upward. They don't create impressive storms. They don't inspire poetry. They simply exist. Large gray or white cloud masses covering much of the sky, often arranged in rounded clusters. They're among the most common clouds on Earth. In fact, vast areas of the world's oceans spend huge amounts of time covered by stratocumulus clouds. From space, these cloud fields can appear almost endless. Millions upon millions of cloud patches stretching across entire regions. And despite their unremarkable appearance, they play an enormous role in Earth's climate. Clouds reflect sunlight back into space. Stratocumulus clouds are especially good at this. Because they're widespread and relatively bright, they help regulate planetary temperatures. Without them, certain regions would absorb significantly more solar energy, which means these boring clouds are secretly helping manage Earth's thermostat. Not bad for a cloud nobody talks about. Scientists continue studying them, because even small changes in stratocumulus coverage could influence climate patterns across the globe. So while they may seem dull from the ground, they are quietly participating in one of the largest systems on Earth. The cirrocumulus cloud. This cloud is rare enough that many people never notice it. And honestly, that's understandable. Cirrocumulus clouds look subtle, tiny cloud fragments, arranged in neat rows high above the Earth. Sometimes the entire sky appears covered with miniature ripples, almost like waves frozen in place. Unlike altocumulus clouds, cirrocumulus clouds exist much higher in the atmosphere. They're primarily composed of ice crystals. And because they're so high, they often appear incredibly delicate, fragile, temporary. They're not usually associated with major storms directly, but they can indicate changing conditions in the upper atmosphere. The strange thing is that many people mistake them for ordinary clouds because they don't stand out dramatically. But once you learn to recognize them, they become impossible to ignore. Suddenly you'll notice them everywhere. It's one of the weirdest things about learning cloud types. The sky you've looked at your entire life starts revealing details you never realized were there. It's almost like unlocking a hidden layer of reality. The cirrostratus cloud. Some clouds create rain. Some create storms. Cirrostratus clouds create optical illusions. These thin, transparent sheets of ice crystal clouds often spread across huge portions of the sky. At first, they may seem almost invisible, but then something extraordinary happens. A ring appears around the sun, or around the moon, a perfect glowing halo. Ancient civilizations often viewed these halos as supernatural signs, messages from gods. warnings of disasters, omens of major events. The real explanation is equally fascinating. The ice crystals inside cirrostratus clouds act like tiny prisms. As sunlight passes through them, the light bends. The result is a giant luminous ring surrounding celestial objects. These halos have fascinated humans for thousands of years. And even today, many people stop and stare when they see one. Because despite understanding the science, it still feels magical. It's one of those rare moments where nature looks like special effects. Except it's real. The lenticular cloud. This is probably the cloud most responsible for UFO sightings. And honestly, it's not hard to see why. Imagine driving through a mountain range and suddenly spotting a giant, smooth disk floating motionless in the sky. No visible movement. No obvious explanation. Just a perfect flying saucer hanging above the landscape. That's a lenticular cloud. Unlike most clouds, lenticular clouds often maintain incredibly smooth shapes. No fluffy edges. No chaotic structures. Just clean, aerodynamic curves. The reason is fascinating. Strong winds flowing over mountains create atmospheric waves. Moist air rises within these waves and cools. As condensation occurs, clouds form in stationary positions. The air moves. The cloud stays, which creates the illusion that the cloud is hovering. For decades, countless UFO reports have turned out to be lenticular clouds. Pilots have reported them. Drivers have reported them. Entire communities have reported them. Because when nature decides to create a flying saucer, it does a surprisingly convincing job. The Cumulus Cloud. There are beautiful clouds. There are dangerous clouds. And then there are clouds that look deeply unsettling. Cumulus clouds belong in that category. Most clouds puff upward. Cumulus clouds hang downward. Large rounded pouches descend from the bottom of a cloud like giant bubbles. The first time people see them, many assume something is wrong. And honestly, they look wrong. Almost as if gravity has reversed itself. These formations often appear beneath powerful thunderstorm systems, particularly Cumulonimbus Clouds. Although Cumulus clouds themselves aren't usually dangerous, they frequently indicate that severe atmospheric activity has recently occurred. Powerful turbulence, strong storms, extreme instability. Pilots pay attention to them. Meteorologists pay attention to them. Because Cumulus clouds often appear after the atmosphere has experienced something violent. And visually, they may be among the most alien-looking clouds on Earth. Some resemble giant hanging sacks. Others resemble a ceiling made of floating bubbles. All of them look like something from another world. The fog cloud. Most people don't realize they've walked through clouds. But they have, many times. Because fog is simply a cloud that decided not to stay in the sky. The science is almost identical. Air cools. Water vapor condenses. Tiny droplets form. The only difference is altitude. Instead of floating thousands of feet overhead, the cloud forms directly at ground level. And suddenly the world changes. Visibility disappears. Buildings vanish. Roads fade into nothingness. Entire landscapes become mysterious. Fog has shaped history in surprising ways. Naval battles were won because of fog. Others were lost because of it. Ships disappeared into it. Armies marched through it. Airports shut down because of it. Entire cities learned to live with it. Some places, like San Francisco, are practically famous for their relationship with fog. And perhaps that's why fog feels different from other clouds. Most clouds are something you observe. Fog is something you experience. You don't just see it. You walk through it. And for a brief moment, it transforms the familiar world into something unknown. The shelf cloud. If you've ever looked toward an approaching storm and thought, that doesn't look normal, there's a good chance you were staring at a shelf cloud. These clouds don't float peacefully overhead. They advance. A shelf cloud often appears as a massive horizontal wedge, stretching across the horizon. Long, dark, menacing. Sometimes, it looks like a giant wall moving toward you. Other times it resembles the front edge of an alien invasion. And in a sense, it is an invasion. Just not from space. From the atmosphere. Shelf clouds form when cool air rushing out of a thunderstorm crashes into warmer air ahead of it. The warm air is forced upward, moisture condenses, and a giant cloud structure develops along the leading edge of the storm. What makes them so dramatic is their scale. Some shelf clouds can stretch for hundreds of miles. Imagine standing outside and watching an entire horizon slowly disappear beneath a giant, rolling structure of cloud. That's what makes shelf clouds famous among storm photographers. People travel enormous distances hoping to witness one. Because unlike many cloud types that appear beautiful or elegant, shelf clouds feel powerful, predatory, like weather with intentions. Historically, communities often feared these clouds because they frequently arrived before destructive winds. Long before radar existed, people learned to recognize them as warnings. A shelf cloud wasn't the storm itself. It was the storm's announcement. Nature knocking on the door before kicking it open. The wall cloud. Few clouds make meteorologists more nervous than a wall cloud, because this is where things can become dangerous very quickly. A wall cloud forms beneath certain severe thunderstorms. Instead of a flat cloud base, part of the cloud lowers dramatically toward the ground. It hangs there, rotating sometimes, growing darker, appearing heavier, and looking alarmingly out of place. This lowered section is called a wall cloud, not because it's shaped like a wall, but because it often looks like a giant chunk of cloud descending toward Earth. The reason meteorologists pay so much attention to wall clouds is simple. Many tornadoes begin here. Not all wall clouds produce tornadoes, but most major tornadoes begin with wall clouds. Storm chasers know this. Weather experts know this. And anyone who has ever watched tornado footage has probably seen one without realizing it. What's terrifying is how ordinary they can seem at first. Sometimes a tornado-producing wall cloud appears almost harmless. Then rotation begins. The atmosphere tightens. The cloud lowers further. And suddenly one of nature's most violent phenomena is born. The wall cloud represents possibility, potential, the moment before chaos becomes visible. The roll cloud. At first glance, roll clouds seem impossible. Imagine a giant tube of cloud. Not a tornado, not a funnel cloud. An enormous horizontal cylinder stretching across the sky, sometimes miles long, completely detached from other clouds, rolling slowly across the atmosphere like a giant wheel. That's a roll cloud. Unlike tornadoes, which rotate vertically, roll clouds rotate horizontally. And despite their intimidating appearance, they're generally harmless. The first time many people see one, they assume something extraordinary is happening. They're not wrong. Roll clouds are rare enough that most people never encounter one in person. When they do appear, social media often explodes with photographs because they look almost computer-generated, like somebody accidentally copied and pasted a giant cloud pipe into the sky. Scientists understand how they form. Humans still struggle to believe what they're seeing. Nature occasionally creates structures so unusual that reality itself begins looking fake. Roll clouds are one of those moments. The asperitas cloud. For centuries, humans looked at clouds and found beauty. Then asperitas clouds arrived and made the sky look angry. These clouds are among the newest officially recognized cloud formations. And honestly, they look disturbing. The underside of the cloud appears turbulent and chaotic. Massive wave-like structures twist across the sky. The entire atmosphere looks as if it's transforming into a dark ocean. Many people describe asperitas clouds as apocalyptic. And that's not an exaggeration. Photographs of them often resemble scenes from disaster movies. The strange thing is that asperitas clouds don't necessarily produce severe weather. They simply look terrifying, which might actually make them even stranger. Humans instinctively associate certain visual patterns with danger. Dark waves, chaotic movement, stormy textures. Asperitas clouds trigger those instincts immediately. It's as if the sky itself has become rough water. And for a few moments, Earth feels like a completely different planet. The Kelvin-Helmholtz cloud. Some clouds look like clouds. This cloud looks like physics. Specifically, physics so beautiful it almost doesn't seem real. Kelvin-Helmholtz clouds resemble giant ocean waves frozen in midair. Perfect curling wave shapes, identical rolling crests. An atmospheric surf break hanging thousands of feet above the ground. Most people who see photographs assume they're fake. Many images have been accused of being photoshopped, but they're entirely real. These clouds form when layers of air move at different speeds. The faster layer slides over the slower layer, creating instability. Eventually, the atmosphere begins behaving like water. The result is one of the most visually stunning cloud formations on Earth. The problem is that they rarely last, often disappearing within minutes. That's part of what makes them so special. You can't plan to see them. You can't reliably predict them. You simply get lucky. For a brief moment, The sky transforms into an invisible ocean. Then the waves disappear, and reality goes back to normal. The pyrocumulus cloud. Most clouds are born from sunlight and moisture. Pyrocumulus clouds are born from fire. Huge fires release incredible amounts of heat. Wildfires, volcanic eruptions, industrial explosions. Anything powerful enough can create them. The heat forces air upward rapidly. As the rising air cools, water vapor condenses. A cloud forms. But unlike ordinary clouds, this cloud exists because something below is burning. Imagine a wildfire so intense that it begins creating its own weather. That's essentially what's happening. Pyrocumulus clouds often tower above major fires, visible from enormous distances. People sometimes mistake them for ordinary clouds. They aren't. They're evidence of immense energy being released below. And as climate change contributes to larger wildfires in some regions, pyrocumulus clouds are becoming increasingly important to study, because sometimes the fire isn't just affecting the weather, it's creating it. The pyrocumulonimbus cloud. If pyrocumulus clouds are impressive, pyrocumulonimbus clouds are terrifying. These are among the most extreme clouds on Earth. A wildfire grows large enough. The heat becomes intense enough. The atmosphere unstable enough. And suddenly the fire creates a thunderstorm. A real thunderstorm, generated by flames. Lightning develops inside the cloud. Strong winds develop. Massive updrafts form. The cloud can reach astonishing heights, sometimes high enough to inject smoke directly into the stratosphere. Visible from space. Think about that for a moment. A fire on the ground creates a storm in the sky. That storm creates lightning. The lightning starts more fires. Those fires create more clouds. The system begins feeding itself. Pyrocumulonimbus clouds are reminders that nature doesn't always separate disasters neatly. Sometimes one disaster creates another, and another, until the atmosphere itself joins the event. The contrail cloud. Most cloud types existed long before humans. Contrail clouds are different. These clouds are our fault. Every time a jet aircraft flies through extremely cold upper air, water vapor from its engines can condense and freeze. A white streak appears behind the plane. That's a contrail. At first it may seem insignificant, but contrails can spread, expand, merge together, eventually transforming into enormous artificial cloud fields. In some regions, contrails have become common enough to influence local weather and temperature patterns, which is remarkable when you think about it. Human activity literally creating new clouds. For centuries, clouds were entirely natural phenomena. Then humanity invented machines capable of drawing lines across the sky, and the atmosphere responded. The sky has always shaped civilization. Now civilization is beginning to shape the sky. The Noctilucent Cloud. Most clouds live in the atmosphere. Noctilucent clouds live near space. These are the highest clouds on Earth, floating more than 50 miles above the surface, so high that even after sunset, sunlight can still reach them. The result is breathtaking. Electric blue clouds glowing against the darkness of night, almost supernatural in appearance. People who see them often describe the experience as magical, because nothing about them looks ordinary. The sky is dark, the stars are appearing, and yet bright luminous clouds remain visible. For centuries nobody knew what they were. Even today, scientists continue studying them because they may reveal important information about atmospheric changes and climate patterns. They're incredibly delicate, incredibly rare, and among the most beautiful things the atmosphere ever creates. The polar stratospheric cloud. If ordinary clouds are beautiful, polar stratospheric clouds are almost unfair. Many scientists consider them the most beautiful clouds on Earth. And, unlike most clouds, they don't simply appear white or gray. They explode with color. Pink, purple, blue, green, orange. Entire rainbows shimmering across the sky. For centuries, people who witnessed them often assumed they were supernatural. Some believed they were signs from gods. Others thought they were celestial portals or strange atmospheric miracles. The truth is almost as fascinating. These clouds form extremely high in the stratosphere, where temperatures become unimaginably cold. Not cold by human standards, cold by atmospheric standards. Temperatures can drop below -100 degrees Fahrenheit. At those temperatures, tiny ice crystals form in the upper atmosphere. Sunlight interacts with these crystals in extraordinary ways. creating brilliant iridescent colors. The result looks less like weather and more like a giant oil painting spread across the sky. But polar stratospheric clouds have a darker side too. Scientists discovered they play an important role in ozone depletion. Chemical reactions occurring on the surfaces of these clouds can contribute to damage in Earth's protective ozone layer. So while they may be among the most beautiful clouds ever discovered, they're also connected to one of the biggest environmental concerns of modern history. Nature has a strange habit of hiding complexity inside beauty. The morning glory cloud. Imagine waking up one morning and seeing a giant white tube stretching across the horizon. Not a normal cloud, not a storm front, a perfectly formed rolling cylinder, hundreds of miles long, moving silently across the sky. That's the morning glory cloud. And it may be the most famous rare cloud on Earth. Most commonly seen in northern Australia, morning glory clouds can extend over 600 miles in length while maintaining their distinctive tubular shape. They're so famous that pilots travel from around the world specifically to experience them. Some even use them like atmospheric waves, gliding alongside the cloud for incredible distances. The first time people witness one, the reaction is usually the same: disbelief. Because it doesn't look like a cloud should look. It resembles a giant atmospheric train, or a rolling wall, or a massive creature moving across the sky. Scientists understand some of the ingredients required for morning glory clouds to form, but the exact recipe remains surprisingly complicated. Temperature, humidity, wind, direction, air pressure. Multiple systems must align almost perfectly, which is why they remain so rare. It's one of the few cloud types that attracts tourists purely for the chance to see it. Most weather is something people avoid. People literally travel across continents hoping to witness a morning glory cloud. That says a lot about how extraordinary it is. The fall streak hole cloud. This cloud looks like someone punched a hole in the sky. And honestly, that's exactly why it became famous. Imagine looking upward and seeing a giant circular gap in a cloud layer, perfectly carved out, like an invisible object passed through the atmosphere. For years, people offered wild explanations. UFOs, secret military experiments, atmospheric anomalies. The actual explanation is far stranger than most people expect. Fall streak holes form when supercooled water droplets suddenly freeze into ice crystals. Once freezing begins, a chain reaction occurs. The surrounding water droplets evaporate rapidly. A giant hole appears. The cloud essentially destroys itself from the inside out. The process can create enormous openings visible for miles. Sometimes the center contains spectacular streaks of falling ice crystals that look like giant white waterfalls hanging from the sky. The phenomenon is so unusual that even experienced pilots occasionally stop to admire it, because few things are stranger than watching a cloud erase itself. It's one of those moments where nature accidentally creates something that looks intentionally designed. The Arcus cloud. Some clouds arrive gently. Arcus clouds make an entrance. These dramatic formations often appear attached to the front edge of powerful storms. Massive, curved, and intimidating, they can stretch across entire horizons. Imagine standing outside and watching a giant dark arch emerge from the distance. The cloud appears to swallow the sky. People frequently mistake Arcus clouds for signs of an apocalypse. And from a visual perspective, that's understandable. Many famous storm photographs feature Arcus clouds because they create such dramatic scenes. They signal strong atmospheric boundaries where different air masses collide. Warm air rises. Cool air pushes forward. The atmosphere becomes organized into a giant moving structure. The result is one of the most cinematic cloud formations on Earth. Hollywood spends millions creating scenes that look like Arcus clouds. Nature creates them for free. The undulatus cloud. Some clouds don't float. They ripple. Undulatus clouds form long wave-like patterns across the sky. Entire cloud layers begin resembling ocean swells frozen in place. The atmosphere suddenly behaves like water. And that's exactly what's happening. Air is technically a fluid. We just don't think of it that way because we live inside it. But when different air layers move together, waves can develop just like they do in oceans. Undulatus clouds make those invisible waves visible. For a few hours, the atmosphere reveals its true nature. A giant flowing sea surrounding the planet. Most people never notice this. But once you recognize undulatus clouds, you start seeing them everywhere. And suddenly the sky feels much more alive. The anvil cloud. The anvil cloud is the crown of the thunderstorm world. If you've ever seen a thunderstorm, spreading outward at the top, like a giant mushroom, you've seen an anvil cloud. This feature forms when a cumulonimbus cloud grows so high that it reaches a stable layer of the atmosphere. The cloud can no longer rise, so it spreads outward instead. The result resembles an enormous blacksmith's anvil, hence the name. Some anvil clouds stretch over 100 miles wide. They can be visible from astonishing distances, and they often signal severe weather. Below, lightning, heavy rain, hail, tornadoes. The cloud itself becomes a billboard, advertising the storm beneath it. What's fascinating is that astronauts regularly photograph giant anvil clouds from space. From orbit, they appear like gigantic white explosions spreading across continents. They are among the largest individual weather structures visible from above Earth, a reminder that storms aren't small local events. Some are atmospheric giants, the cloud that doesn't exist yet. This might sound strange, but the future may contain cloud types humans have never seen before. Earth's atmosphere is constantly changing. Climate patterns evolve. Temperatures shift. Human activity influences weather systems. Scientists continue discovering new cloud classifications even today. In fact, asperitas clouds were only officially recognized in the 21st century. Think about that. Humans have stared at the sky for tens of thousands of years, and we're still finding new cloud types. The atmosphere remains one of the most complex systems on the planet. There may be cloud formations waiting to be discovered right now, somewhere above an ocean, above a desert, above a mountain range. Invisible until the perfect conditions reveal them. The sky still contains mysteries, and that's a surprisingly comforting thought. The strange thing about clouds is that most people stop noticing them. They're always there, every day, every season, every year of our lives. And because they're familiar, they become invisible. But clouds are among the most extraordinary things on Earth. Some create thunderstorms powerful enough to shake entire cities. Some glow near the edge of space. Some look like UFOs. Some look like ocean waves. Some create rain that feeds civilizations. Some emerge from wildfires. Some only appear in specific corners of the world. And some are so rare that most humans will never see them in person. All of them are temporary. Every cloud you have ever seen existed for only a short time before disappearing forever. A unique shape that will never form in exactly the same way again. Maybe that's why people have spent thousands of years staring at the sky. Because clouds constantly remind us of something important. The world is changing every second, even when it looks still and above our heads. That change is always visible for anyone willing to look up. Like and subscribe to Think Rare for more such explanation videos.